few things travel at constant speed. Most are either getting faster or slowing down. During this golf swing, the speed of the club is changing. Freeze the action every 20th of a second, and the distance travelled by the club head varies. The time interval stays the same, but the distance travelled increases and then decreases. Speed is distance moved divided by time taken. If the time interval stays the same, but the distance travelled changes, the speed must be changing too. When the speed of an object increases, we say it accelerates. To investigate acceleration, a lightweight glider is pulled along a linear air track. It's attached to a tape that's weighted at one end. As the mass falls, it pulls the vehicle forward. To analyse the change in speed, light gates attached to electronic timers are placed at half-metre intervals. As the vehicle passes through the first gate, all the timers start. As it passes through the next light gate, the first counter stops, and then the second, and then the third. To cover the first half a metre, it took 1.8 seconds. The timer reads 1.8 seconds at the start of the next half metre, and 2.6 at the end. To travel the second half metre, it took 2.6 minus 1.8, which is 0.8 seconds. To travel the third half metre, it took 3.3 minus 2.6, which is 0.7 seconds. Plotting a graph of distance against time produces a curve. The vehicle is taking less time to travel each half metre. Its speed is increasing. To find out what happens when the vehicle is pulled with a greater force, another weight is added. This increases the pulling force. How will it affect acceleration? To travel half a metre, it took 1.4 seconds. To travel 1 metre, it took 2 seconds. And to travel 1.5 metres, it took 2.4 seconds. Increasing the force decreases the time taken to travel each half metre. The curve is steeper. Increase the force again, make a note of the results and see how the time taken for each half metre changes.